Hello and welcome everyone. Thanks for joining me today. My name is Senthil Padmanabhan. I'm a VP Technical Fellow at eBay. I run the developer platform, but which also includes user experience engineering. So today we are going to talk about embracing AI in UI. So let's get started. As most of you are aware, machine learning is embedded in every part of user interaction. Sometimes it's obvious, sometimes it's not. Right from the time you do a simple search query to your whole journey in e-commerce or booking your vacation, or even you click on a payments button to check whether the user is fraudulent or not, or even when you ring your doorbell, there is machine learning involved. And it's very simple, right? The reason is we are trying to build very complex use cases, and the traditional rules-based engine programming doesn't work. And also we have tons of data, and so everybody defaults to machine learning as the way to go. However, we should also realize that customer expectations are changing over time. This is how things evolve. Over time, customers' behaviors change. And what we are noticing these days is that more and more customers expect products to be privacy preserving, always available, and instantly responsive. It's a big statement. Let me try to break it up for you folks. So first is privacy. We do a lot of things online, especially after the pandemic. This has become a forcing function. And many things we do online are personal info, personal stuff, and personal stuff has to be private. We don't want the whole world to know what we are doing, and sometimes we don't even want the company who offers the product to know what we are doing because it's very personal to us. So this has become like a very default expectations. The next one is about availability. It's not only good for your business, but also customers don't look at your product, an unstable product, as trustworthy. They lose trust in your product. They may go to your competitors. It's just not stable stakes at this point. At least the minimum basic interactions should be always available, irrespective of what environment the product is used in. And the last is about speed. As more and more younger generation come online, they expect things to be very quick. They don't like to see a throbber. They don't like to wait. And that's again become expectations from them. And it's also about consistency. It's not about, one interaction being super fast and the other being slow. They want consistently fast experience, and that's what they are expecting. So we have all these requirements, and how do we achieve that? There are many ways to do that. The one thing that I'm going to talk about today is on-device computing. So we all carry devices with us. It can be your mobile phone or your laptops, desktop, and why don't we start leveraging them to qualify for these three expectations that customers are asking us. So before we get started, I also want to set the context of this talk. So this talk is not about using AI or ML to design or build your user experiences. There is a whole research or study here and products that says that, hey, I'll use AI to design your product or generate software that you can just give it to your customers. This is not about that. This is about bringing AI and ML closer to your users' devices. That's what this talk is about. So let me quickly, most of you probably know it, there are two major phases in ML. There are many phases, but at a high level, there are two major phases. The first one is the training part. As many of this is the teaching, right? You teach the system what to do. And this is where you are model building. You take a large amount of data and you put it into a model building phase. And the model building is where your feature extraction happens. You apply weight, you adjust your loss functions, you tweak your algorithms. And finally, you get an output, which is the model. And the model is just a mathematical function, which is going to predict something. And the next phase is the inference phase. So what do you do with your model? And that's where inferencing comes. The user interacts with your model, the model gives you a result, and the result can be a prediction, it can be a classification. So the user uploads an image, and the model can say it's a cat or a dog. And in most cases, training happens offline and inference happens online. Training happens offline, meaning it happens in its own timeline. It happens behind the scenes. Engineers and scientists go and build their model and publish it in their own timelines. Whereas inference happens real time. When a user actually interacts with your product, that's when inferencing happens. And I mention most because sometimes training also happens in real time in some scenarios, but majority of the cases it's offline and online. Our focus today is going to be on the online, like on the real time, which is the inferencing part. Let me also talk about a typical workflow. So when a user interacts with with a device or with your product, they interact with the device. And what the device does is it makes a call to the cloud. And what's inside the cloud is basically a model being wrapped in a service, and then it's going to serve your request and send a response saying, okay, you requested something, this is the response. The software on your device goes and shows that to your customers, right? An optimized workflow would be something like this. You take the model from the cloud, you move to the device itself. You basically cut the call to the cloud and do the inferencing on your device. See, all of the devices that we are carrying are getting powerful day by day. So why don't we start leveraging them to do this inferencing, right? But let's first verify whether doing this will satisfy all our customer expectations that we have outlined in the beginning of the talk. The first thing is privacy. So none of the data leaves your device. So it's private by default because the inferencing happens right on real time, right in your device. Next is availability. It has to be available because if your machine or if your mobile device is on and up and running, it has to be available. You are not dependent on somebody keeping the service up and running, or you're not dependent on some cloud provider keeping it up. And lastly, it's about speed, responsiveness. The quickest request is a request that's never made. And in this case, you're not making any network request, so the response has to be fast, so the data has to come quickly. So the question that people keep asking is, then why are we not always doing this? It seems to be like the most obvious thing to do, so everybody should start putting their models on the devices and things like that. The answer to that is it's much more complicated to put it into practice. And that's one of the reasons that this adoption has not happened in the way we want it to happen. For that, we first have to talk about model quality. Model quality is like how good your model is. Like, is your model doing what it's supposed to do? So, among other things, the quality or accuracy of your model depends on two critical factors. There are many things, but mainly two factors. One is the size of your model, how big or small it is, and the next is your available computation power, how good is your CPU or GPU. And in general, a high quality model is something that needs a large size and it's very computationally expensive. So that's how, usually, if a model has to be really good, it is qualifying in these two criteria. But I really understand the constraint. The devices, especially mobile devices, are constrained on both. Yes, they are getting powerful day by day, but when compared to your cloud, it's uncomparable because in cloud you have unlimited access. You just have to write a big check, but you can get all your TPUs and GPUs into the system, and you control how your software scales. Whereas on the device, whatever the user's device have, you don't have any control on the hardware what they do. So this is where the biggest constraint is, that everybody is not able to do that. Does it mean it's the end of the story? So are we discussing that? No, it's still possible. There are techniques and use cases that can benefit from on-device inferencing. We just have to pick the right battle. So how do you make progress? So first, identify the use cases that will benefit from this approach. Not every use case or every interaction in your product needs to have these three features, these three expectations satisfied, and it's just not possible. If you do that, then you'll go the other way around and you'll make the whole experience bad for your customers. So first, try to choose your use cases that really are critical for your users, which privacy matters, responsiveness matters, availability matters, and then try to optimize it. And next is to apply techniques that will enable this approach. There is an area of research that's going on, and we need to go into see those techniques and try to enable them. So this is the change in thought process that I've been talking about, right? When we need to embrace this idea right when designing the user experience, rather than this being an afterthought. Right? When we build user experience, we think about various things. We think about interactivity, accessibility, how to represent your brand, end-to-end user interactions. We also think about clutter, how to avoid clutter. There are a lot of things which go into when you are designing a product, but we are not thinking in these three areas. That's very critical going forward, and that's what we should start doing. We should have this change in thought process when we are designing a product itself. So I want to quickly talk about techniques here. So we're not going to go deep dive into this. There are many areas that's happening here, but there are two main techniques that I want to highlight. One is quantization, and the other is classification and pruning. So quantization is a technique that for some folks would have been aware, where you take a high bit, where you take your model parameters or your tensors, and you convert them from a high bit width number to a low bit width number. It's basically taking a 32-bit floating point number and converting them to an 8-bit integer without sacrificing accuracy. That's the key here. So you want to lose some precision on those numbers, but that's fine for certain cases. It's just that the model still has to be accurate. It has to have a high batting average. That's what you have to look into. The next technique is classification or pruning. As the name suggests, it's like reducing the size of the model. And the way it is done is we take a high dense model and convert it to a sparse model by gradually setting a fraction of your weights to 0 during training. Again, both of these techniques are well known in the industry, but there's a lot of research, but we don't look into it in the way we have to, because we don't think about on-device computing as a way that we have to go and enable these things for. So let's talk about how they. So both of these techniques will have an impact on your performance, right? Because in quantization you need less computation now. Less computation means you consume less of your mobile devices power, which means you drain less battery, which is very important for your mobile devices. Because if you do a lot of computationally expensive stuff, your battery drains very quickly. Second is again with sparsification, you get your model size reduces, which means you use a low memory bandwidth, low storage. Again, it increases performance. So both of these techniques have a good impact on how performance, your model's performance. Now let's talk a little bit about use cases. And here I want to talk about a real world use case because we can talk about it in theory, but only if it has a real customer impact, it actually makes sense. And the use case I want to talk about is eBay image cleanup, a product which we launched 2 years back. And what is image cleanup? Image cleanup is a computer vision powered tool on mobile platforms for creating images with clean white backgrounds. If you take a lot of regular users, regular casual sellers, when they take an image, there is always background clutter on it. And this project is about removing that background clutter, so it looks good. We launched it 2 years back, and there was a lot of good media coverage about it. But more importantly, I want to talk about what was the motivation for us to do it, and what is the opportunity that we felt that we had to do it. Let's first talk about the motivation here. So it's so when we launched this product, we thought about, okay, this is the best first expression we can give when listing an item on eBay. A lot of casual users are not repeat sellers, or they just come to list one item and go. So the first impression really matters in those scenarios, and we want to give them a very good impression. And this is the first thing they do. They take an image. That's the first step in any listing flow, and we want that to be a very good impression. So what happens because of it is we have a better draft completion rate. If you see any two-sided marketplace, especially a marketplace that has a listing, it's a very the draft completion rate is a very important metric. This is the metric like how many users who start the listing go and publish it to the marketplace. Surprisingly, a lot of marketplaces suffer from this because it's very easy to start a listing and then it asks like tons of questions. The image is not good, people lose motivation and they drop off. It's a very common thing because you have to set up payment, shipping, ton of other stuff. So we can see that if you have a good impression, people are more motivated to go and complete the listing. The next is equal opportunity for both professional and non-professional sellers. See, non-professional sellers do not have the resources that professional sellers have, and we wanted to bridge that gap here. And that ties with the core value of eBay, which is economically empower everyone, no matter who they are. And finally, we thought, okay, why don't we keep talking about this sort of change in thought process? Why don't we start applying it in one use case? And this was the first use case which made sense for us. Now let's talk about opportunity here, right? Most small non-professional sellers use their phones to take pictures. They do not have access to these fancy cameras that all these professional photographers have and all the fancy studios that they have. So they use their phones to take, and this is a very good use. That's the opportunity for us to leverage that. Next, eBay can be an all-in-one app for listing creation, both photo taking and image processing capabilities. A lot of times professional sellers, they take a photo, then they put it in another software to make it look beautiful and things like that. So it's actually overhead, right? Every step in your way is a friction. That's okay for professional or business sellers, but that's very tough for a regular like casual sellers. So we can have eBay as that one app, that the flagship app eBay has, can do all those things for them. And finally, this was also an ideal use case to satisfy customer expectations, because this is one important scenario where it has to be always available for us, because taking the picture, if you have them take a picture, I think they're almost committed to us, right? So that's the first step, and it has to be quick. It cannot take a long time because these people, the people come, they go, the patience level is so low. And a lot of times there is also a privacy angle to it, because only when the users see the picture, they really decide whether they want to go with the listing or not. So it sort of satisfied all our criteria, and we thought, okay, let's go ahead and try this one. So how did we do it? So we took a computer vision model and a C++ library, and we bundled it as a part of our iOS and Android, both for Apple and Google builds. The goal for inference algorithm was to separate the foreground from the background clutter. It's simple, so I can show it in an image. So if you see here, the sweater is the foreground, and the background is the cream background that it has. So our goal is to separate the foreground from the background. So the algorithm's output is a mask that's made up of the probability of the foreground of each pixel. So it gives you a mask, and that mask tells you, okay, what is the probability that this pixel is a foreground or not. In this case, this is how the mask, the output of the mask looks like. So you take the picture, and then it generates this mask, and then you can see how much the probability of it. And finally, how do you know your model is doing good or not? And that's where the confidence scoring comes into play. So the confidence in background removal is measured by a factor that we call separability. That is, how easy it is to separate the foreground from the background. So higher separability, it is better. So that your model gets better and better over time. So in this case, it has a high separability, and this is a real world image itself that happens. And so that's how the last final image you see, that's how you get it. And that looks more professional than the first image that you took, which was just hanging in your closet or wherever, right? So this is what the algorithm did. And when we launched it, we did a testing around it where 5.5 million sellers were engaged with this tool. Very good. We saw active engagement, but more importantly, 77% of those drafts were published to the marketplace, which is higher than a usual scenario. Just because the image was good looking and things like that, that motivated people to go and, yeah, let's go and publish our image into the marketplace. I also want to call about a few other use cases that we use at eBay. So one is trading card recognition. Trading card is a very big category at eBay, especially during the pandemic. Every minute, eBay, like 119 listings were, people were listing 119 trading cards on eBay every minute, and every minute 90 trading cards were sold on eBay. During the peak of the pandemic, right? I think we were all at home. Trading card was a big deal that time. But so we also thought that we need to enable our sellers quickly, and trading card is also a lot of personal things. A lot of people have a lot of emotional attachment to trading cards. And first thing we wanted to do was, okay, you decide before you upload to eBay whether this trading card is worth selling for you or not, and that's why we made it all on device. And the way it works is we have an ML kit as well as, so we used a lightweight ML model along with the ML kits that come with your iOS and Android devices, and that made it happen. The next use case is condition grading. A lot of times users want to know whether this item is a new item, used item, like new, and that can happen quickly on the device itself. So that's another scenario that we try to do. So I want to also call about a few industry use cases here. So the first one is cameras in modern phones. All of us carry a phone with us, right? And the way and everything in a camera happens on device inferencing, right? The way your night vision works or your portrait mode works, all of that is because on device inferencing. If it was supposed to go to a cloud, we would all be hesitant to do that because photos are very personal. We take photos everywhere, and we have to decide on where it has to go and saved, and it cannot go every time to the cloud and get processed for you. So all the processing that you happen on your cameras happens on device, which is a beautiful use case that we can see on how these things happen. The next is grammar suggestions and hate speech detection. So a lot of people, including myself, we use grammar a lot when I'm writing and authoring documents. And I don't want those content or text to go to the cloud, right? It's my personal thing, and I want it to be in device, and I want it to be fast, available. I'll be in a plane doing these things. So these things has to happen, and that's a very good use case where model can run on your laptop whenever you're authoring content. Another use case is a low bitrate speech compression. So whenever you're doing audio exchanges between people, in common scenarios is that the speech gets transmitted to an intermediary which does the compression and then transfers it to the other person. In this case, LiDAR is a good model that I can showcase where this one happens on device itself. It's a very lightweight model. It uses the techniques that I told you about sparsification and quantization and makes it happen. And lastly, interaction with smart devices. A lot of people have smart devices at home, and a lot of interactions we do with it are all private, personal. Right. In fact, a good example is the Nest Hub, I guess, which has a sleep monitoring, like which says how good your sleep is, and that all happens on device because we'll be freaked out if somebody gets to know what our sleep pattern is on a day-to-day basis. So with that, I want to conclude this talk by saying, putting forth this idea to all of you, right? We need to start embracing AI in UI. And the way we do it is we start evaluating use cases against these three principles: privacy, availability, and responsiveness. As I mentioned earlier, not every use case is worth this. So pick your battles, choose the right use case, and then try to put them into this practice. And then finally incorporate them as a part of your UI design and development process itself, rather than that being an afterthought. Like a lot of times we do that, and after we do it, we think, oh, it should have done it this way. I think instead of that, just move to earlier in your product development life cycle, and you'll see a lot of gains over there. Thank you.